Hello, this is the luckiest maths teacher in the world today. We're solving quadratic equations. Now, I know you're already familiar with solving linear equations. So let's just take a look at one of those for a second. So let's say we have 2x plus 9 equals 29, or whatever. So this is a linear equation because we have a linear function. It's of the form mx plus b. And what we want to do is we want to find a value that we can substitute for x that makes this statement true. So of course, the answer here is 10, because if I take away the x and I change it to 10, I get 2 times 10 plus 9 equals 29, and that is a true statement. If I put in any number other than 10, it will be wrong, right? I know you all know that. You know, you're probably thinking, wow, this isn't exciting. But now we're going to look at solving quadratic equations. And they involve, of course, quadratic functions. So remember, a quadratic function is something times x squared plus something times x plus something. Now, of course, the b or the c might equal 0. So let's say we have something like this. X squared equals 16. Okay, now I know that you know how to solve this really easy. We can just take the square root of both sides, as long as we do to one side what we're doing to the other, and that's nice and easy, in fact. But one thing I want to point out that is, I guess, slightly obvious is that this equation, unlike the one over here, the linear equation, this actually has more than one solution. It has two solutions. So if x squared equals 16, the two solutions we write like this, they are 4 and minus 4, because if I substitute 4 for x, I get a true statement, 4 squared equals 16. If I substitute minus 4 for x, I get minus 4 squared equals 16. That is, again, a true statement. There are some times when a quadratic equation has one solution. If I have x squared equals 0, that only has one solution, x equals 0. Again, we take the square root of both sides, and x equals 0. So we had two solutions in the first one and only one in the second one. But just to make things even more crazy, sometimes we have no solutions. If I have the equation x squared plus 1 equals 0, I can subtract 1 from both sides like a normal linear equation. I get x squared is negative 1. Now this actually has no solutions because you cannot square a number to get a negative number. Because if x is negative, squaring it will make it positive. If x is positive, squaring it will make it positive, okay? So there are a few differences we see already in the number of solutions. Now you're probably thinking, wow, these quadratic equations are easy. We just follow the same process as linear equations, but use the square root function to undo x squared, right? Unfortunately, life isn't that simple. See, what makes these three equations, even though there were a different number of solutions, what makes them easy is that the x is only in one place. But there are harder quadratic equations where the x is in more than one place, and that occurs when, of course, b doesn't equal 0. So when you have something like, let's say, x squared plus 6x plus 8, for example. Let's say we have x squared plus 6x plus 8 equals 0. Now this is a little more complicated because the x's are in two different places. So we can't do the normal linear equations process. We can't, minus 8 divided by 6. That will get us nowhere. Absolutely nowhere. When you have a quadratic trinomial like this, or where you have a quadratic binomial, whenever the x is in more than one spot, as it is here, what you need to do is factorize. And that is precisely why we've gone through factorizing for a while. So this is what we end up doing. We end up writing this as something times something equals 0. So we're going to factorize this expression here. Now, what we're going to do then is apply what's called the Null Factor Law. If I have two things, so one thing here and one thing here, that multiply to 0, either the first thing equals 0 or the second thing equals 0, right? That doesn't work for any other number. If I say two numbers multiply to give 4, can't really tell me much about the numbers. They could be, 4 and 1 or 8 as well as a half, whatever. But when it's 0, you can say that either or both of the things must equal 0. And that's where the two solutions come from. That's why the quadratic equations sometimes have two solutions. So what we do is we factorize, we get something like this, something times something equals 0. Then we find what value of x makes the first something equal 0, that's one solution, and what value of x makes the second something equal 0, and that's one solution. Okay, so I'm going to go ahead and actually do this question on a new slide, so please copy down anything you need. So let's go ahead and do this. So I know you know how to factorize this. This is a monic quadratic. So what we do is we write our two brackets. We have x and x in them, and we find two numbers to go in these boxes, and they are two numbers that multiply to give 8 and add to give 6. So if you go through the factors of 8, those are 2 and 4. 2 plus 4 equals 6. 2 times 4 equals 8. So, because this is the same as that, we have x plus 2, x plus 4 equals 0. So using the null factor law, we have either x plus 2 equals 0, which means x equals minus 2, or we have x plus 4 equals 0, in which case x equals minus 4. Now the thing is that if I substitute x is minus 2 into the original equation, it will make it true, because minus 2 squared plus 6 times minus 2 plus 8, so that just equals, minus 2 squared is positive 4 minus 12 plus 8. 4 minus 12 plus 8 does in fact equal 0. So x is minus 2 makes the statement true, therefore it's a solution. And the same thing would happen if I substitute x is minus 4. So this quadratic equation has two solutions. So when the x is in more than one spot, as it is here, you factorize using the techniques that we've gone through. So now I'm going to do another example, but I'm going to do it quicker. So let's try this one, x squared minus 4x equals minus 4. Now again, the x is in more than one spot, so we don't try and treat it like a linear equation and get all the x's to one side. We want everything on one side. One side has to equal 0, otherwise we can't use the null factor law. So the first thing I'm going to do here is I'm going to add 4 to both sides so that this side of the equation equals 0. Then I can use the null factor law. So that simply becomes x squared minus 4x plus 4 equals 0. Now I factorize and I find the solutions. So this is again a monic quadratic, so we have to use that idea. So x squared minus 4x plus 4 equals 0. So two numbers that multiply to 4 and add to negative 4, they're both minus 2. So I get x minus 2 squared equals 0. So of course that means that x minus 2 equals 0 and x equals 2. So this one, unlike the previous example, has only one solution. And as I said, quadratic equations can have 0, 1 or 2 solutions. We're mostly focused on the 1 and 2 solutions. You'll come across more of the no solutions later. Here's another one. So let's say we have 2x squared plus 8x plus 6 equals 0. So again, this is a non-monic quadratic, but there is a common factor to all of the three terms, so we take that out. So 2x squared divided by 2, 8x divided by 2, 6 divided by 2. Now when you're solving, not just when you're factorizing, when you're solving, you can cancel out this 2, because if 2 times something equals 0, then obviously this something has to equal 0. 2 can't equal 0. Essentially, we're dividing each side of the equation by 2. So then we just factorize what's left, x squared plus 4x plus 3. So two numbers that multiply to 3 and add to 4 are, of course, 3 and 1. So x plus 3 equals 1, then that means x equals minus 3. If x plus 1 equals 0, x equals minus 1. They are the two solutions. Now I'm going to do one more of the non-monic type of questions, so please copy these down if you need. Okay, so let's try this one. 3x squared minus 11x plus 10 equals 0. So we've got one side equal to 0, which is great. We don't need to do anything to it. So all we do is focus on factorising this here. So we use the processes we went through last lesson. So A times C is 30. Now we need to find two factors of 30 that add to negative 11, and they of course are negative 6 and negative 5. So then we split up the middle term, minus 11x. So our quadratic becomes 3x squared minus 6x minus 5x plus 10 equals 0. And we factorise by grouping in pairs. So first two terms, highest common factor is 3x, and then what goes in the brackets is x minus 2, and then of the next two terms, we're going to take out a factor of minus 5. So minus 5 times x gives minus 5x, and minus 5 times negative 2 gives positive 10. Of course, now we have a common factor, so we have x minus 2 out the front, and just what's remaining in the brackets there. Okay, so our two solutions to the quadratic, either x minus 2 equals 0, and if x minus 2 equals 0, then x just equals 2. That's just a linear equation, you know how to solve. 3x minus 5 equals 0, so again, we just use our linear techniques now. 3x equals 5, so I've added 5 to both sides, and you divide each side by 3. So they are the two solutions. All right, I hope you've enjoyed this video. Please make sure that you remember one side has to equal 0, then we factorise. This has been the luckiest maths teacher in the world. Have a great day.